All right, everyone, welcome back. Today, we're going to do a deep dive into something uh, pretty crazy. Remember that massive Microsoft outage back in 2024?
Oh, yeah. How could anyone forget that? Millions locked out of their computers, businesses at a standstill. Chaos.
It was wild, right? Flights grounded, hospitals having to postpone procedures, the whole 9 yards. And guess what? It all came down to, get this, a tiny software update. One little update gone wrong, and boom,
Hmm.
global digital meltdown.
It really shows you how interconnected everything is these days, right? Like one little glitch can have ripple effects across the whole world.
Absolutely. So the company at the center of it all was CrowdStrike, the cybersecurity
You
company.
got ones at the Falcon sensor, right?
Yep, exactly. That's the security tool they make for Windows, basically. It's supposed to be like a watchdog sniffing out threats on your computer.
But this time, the watchdog kind of bit the hand that fed it, you know?
Yeah, no kidding. So a bad update to this Falcon sensor, it basically set off a chain reaction, and Windows systems just started crashing left and right. That dreaded blue screen of death,
No,
remember?
yeah, the BSOD classic.
And just to be clear, this wasn't some hacker attack or anything like that, purely a software bug, just an internal error that, well, you know, spiraled out of control on a global scale.
And CrowdStrike was pretty quick to own up to it, right? They yanked the bad update, and George Kurtz, their CEO, he even apologized publicly.
He did, yeah. So they were doing everything they could to fix things. But the big question is, how did this even happen in the first place? What was the technical, root cause of all this
Hmm.
chaos?
Well, it all boils down to these things called channel files. Think of them as the delivery system for updates to those Falcon sensors. They keep those sensors armed with all the latest threat info.
So, channel files are the supply trucks bringing fresh ammo to the watchdogs. Got it.
Yeah, exactly. Now, with version 7.11 of the Falcon sensor, they introduced this new thing called IPC template type, right? It was supposed to boost security, give the sensor a better view of what's going on between different processes on Windows.
So, like giving the watchdogs night vision goggles.
Perfect analogy. But here's the thing. This new template, it needed 21 specific pieces of information to work right.
21, okay.
But for some reason, the code was only giving it 20.
Ah, someone forgot to pack all the gear for the night vision goggles.
Yeah.
So what happened? Did it just not work?
Well, it wasn't caught right away because during testing, they were using wildcard criteria for that 21st input.
So, they were using dummy batteries in the goggles during training. No one realized they were noting a real one.
Exactly. And to make matters worse, on July 19th, CrowdStrike pushed out a new channel file that didn't use a wildcard for that missing piece of info.
Uh-oh. And that's when everything went haywire.
Bingo. The sensor's content interpreter, that's the part of the code that handles these channel files, it hit what's called an out-of-bounds read issue. It tried to access a value that wasn't there, and boom, system crash.
Like the watchdog tried to flip a switch on the goggles that wasn't there and the whole system shorted out.
Precisely. And since millions of computers were running this updated sensor, it was a domino effect, crashes everywhere, leading to that massive outage.
Okay, so we've got the watchdog analogy down, but let's get a little more technical for a sec. Can you break down this out-of-bounds read issue a bit more? What happened at the code level?
All right, well, imagine you've got a row of mailboxes numbered 1 through 20, right?
Okay, I'm picturing it.
And you're expecting a letter in mailbox number 21, but that mailbox doesn't exist. So when the mail carrier tries to deliver that letter to mailbox 21.problem, they're trying to access a spot that's beyond the existing mailboxes.
So in this case, the content interpreter was expecting that 21st piece of data, but the code hadn't actually made space for it.
Exactly. It tried to access a memory location that wasn't allocated, and that caused a memory access violation, leading to the crash.
Classic programming error, but with some pretty huge consequences in this case.
No kidding. It really highlights how important robust testing and validation are in software development, especially when you're talking about software that operates at the system level.
So what did CrowdStrike do to fix this? Did they just add the missing info and call it a day?
It was a bit more involved than that. They did a bunch of things, like adding validation during compilation and runtime checks to the content interpreter.
Hold on, let's unpack that a bit. First, adding validation during compilation. What does that even mean?
Okay, so during compilation, which is basically turning human-readable code into something the machine can understand and execute, they added checks to ensure that the number of input fields in that IPC template type definition matched the number of inputs expected by the content interpreter.
So they're double-checking the blueprints before building the house, making sure everything lines up.
Exactly. It prevents mismatches from slipping through during development.
Smart. And what about those runtime checks they added?
Those are like safety nets. Even if a mismatch somehow gets past the compilation stage, these runtime checks will catch it when the content interpreter is actually processing the channel files. They stop it from trying to access memory locations that don't exist.
So adding guardrails to prevent the software from veering off the road.
You got it. They're crucial for preventing these kinds of errors that can crash the system. And the third thing they did was prevent the creation of those problematic channel 291 files altogether.
How'd they do that?
They'd changed the content validator, which is responsible for checking those channel files, to only allow wildcard matching criteria in that 21st field. So any channel file trying to use something else gets rejected.
So they lock the door to that 21st mailbox. No more mail going there.
Perfect analogy. By doing that, they eliminate the chance of the content interpreter running into that out-of-bounds read issue again.
So they put multiple layers of defense in place to prevent this from happening again. But did they address the bigger issue of, potential memory access violations in their software in general?
Oh, yeah. They definitely took steps to improve their testing and validation processes overall. They realized that what they were doing before just wasn't good enough.
Can you expand on that? Like, what specifically did they change about their testing?
Well, they realized they needed to test a wider range of matching criteria, especially things that might cause unexpected behavior. They also started doing more rigorous stress testing, trying to mimic real-world conditions to find weaknesses.
So they're really trying to break their own software before anyone else can.
Exactly. Trying to think of every scenario and make sure their software can handle it without crashing or causing instability.
Makes sense. So we've got the technical stuff down, but what about the impact of this outage? We mentioned flights grounded, hospitals delayed. What were the real-world consequences of this software bug?
Oh, the impact was massive. We're talking businesses of all sizes affected, disruptions, productivity loss, financial setbacks, you name it.
It's hard to wrap your head around the scale of it all. Can you give us some concrete examples of how businesses were affected?
Absolutely. So you've got all these companies that rely on cloud-based services these days, right? Email, file sharing, customer management, all that stuff.
Yeah, so much of business runs on those services now.
Right. And with Microsoft services like Outlook and Teams down, communication and collaboration basically stopped for a ton of organizations.
It's amazing how much we depend on those services without even thinking about it until they're gone.
It is. And it wasn't just offices either. Think about retail stores. Many of them use cloud-based systems for their cash registers.
Oh, right. I remember hearing about people stuck in lines at stores because the registers weren't working.
Exactly. And it went beyond retail. Transportation and logistics were hit hard too. Airlines use cloud systems for flight scheduling, baggage handling, all of it.
So flights grounded, airports in chaos.
Total logistical nightmare for everyone involved. And then you've got financial institutions. Their online banking and trading platforms were disrupted. Schools couldn't access online learning platforms. Even government agencies had delays in processing things and providing services.
Wow, so this outage really showed us how fragile our digital world is, how much we rely on a few big tech companies.
It was a major wake-up call for sure. It showed that our interconnected digital world is only as strong as its weakest link, and in this case, that was a seemingly tiny software bug.
It really makes you think about the consequences of software errors, especially when that software is so integrated into everything we do.
Absolutely. And it emphasizes how important strong security practices are, rigorous testing, and having plans in place to mitigate these kinds of events.
So we've talked about what caused the outage, the impact it had, and the bigger picture of our digital infrastructure. But what about CrowdStrike's response? Did they just fix the bug and move on, or did they try to, rebuild trust with customers in the industry after this whole mess?
They took a pretty multi-pronged approach to address the situation, actually.
Okay, I'm intrigued. What did they do?
Well, first off, they went beyond just fixing the immediate bug. They did a deep dive into the root cause to understand what led to this whole thing in the first place.
So they didn't just slap a Band-Aid on it. They wanted to find the source of the problem.
Exactly. They needed to figure out if there were weaknesses in their development, testing, or quality control that let this bug slip through.
And what did they find?
Their analysis showed a few areas they needed to improve, like that need for better validation during compilation, those enhanced runtime checks we talked about, and tighter control over creating those channel files.
So they basically admitted that their safety measures weren't good enough and needed to be beefed up.
Exactly. They recognized that one single point of failure had taken down a huge chunk of the internet, and they had to put multiple layers of defense in place to stop it from happening again.
And did they tell anyone about their findings?
Oh, yeah, they were pretty transparent about it. They published a detailed report explaining what they found, what they were doing to fix it, and how they were going to prevent it from happening again.
So they owned up to their mistakes and were upfront about how they were going to fix things?
Exactly. Transparency was key for them. They knew they had to be open and accountable to rebuild trust.
And did they change anything about how they test their software to make sure this doesn't happen again?
For sure, they seriously ramped up their testing. They expanded their testing to cover more scenarios, especially those edge cases that might cause unexpected behavior. And they got really serious about stress testing to simulate real-world conditions. Plus, they started doing staged rollouts, so new updates go out to smaller groups first before a wider release.
So they're trying to break their own software before it gets out there, and they're being super careful with updates to avoid another massive disruption.
You got it. They're being much more proactive about quality assurance and risk mitigation. They've learned that even a little bug can have huge consequences.
It sounds like they're taking this whole thing seriously.
They are. They've made changes to how they develop, test, and control the quality of their software, and they're committed to ongoing review and improvement so their software meets the highest standards of reliability and security.
So it's not just about fixing this one problem, but about learning from it and finding long-term solutions.
Absolutely. They're realizing that cybersecurity is a constant process of adapting and improving. You can't just react to things after they happen. You have to be proactive and find potential risks before they become problems.
And in this case, it seems like they've taken some big steps in the right direction.
They have, and I think their response is a good example for other software companies. It shows the importance of transparency, accountability, and constantly striving to improve.
So this outage was a major setback for Microsoft and CrowdStrike, but it was also a chance to learn and grow.
Definitely. It showed how crucial strong security practices are, how important thorough testing is, and how transparency and accountability build trust and resilience in the digital world.
And it reminded us that even the most sophisticated technology is vulnerable to human error.
Very true. It's a reminder that we need to stay vigilant, proactive, and adaptable when it comes to cybersecurity. We always need to be finding ways to strengthen our defenses and stay ahead of new threats.
It's a never-ending game of cat and mouse, right?
It is. But with each incident, we learn valuable lessons that help us build a more secure and resilient digital future.
So let's switch gears a bit and talk about what this outage means on a broader scale. It really showed how fragile our interconnected digital world is and how one thing can set off a chain reaction. But what can we actually do about it? How do we make sure something like this doesn't happen again?
That's the million-dollar question, isn't it?
Yeah.
Well, I think there are several key takeaways from this whole incident that can help us make our digital infrastructure stronger and more resilient. Yeah, like a defense in depth strategy. We can't just be playing catch-up, trying to fix things after the fact.
Right, gotta be proactive.
Exactly. We need multiple layers of protection starting way back at the beginning when the software is being designed and built.
So instead of relying on one guard dog, we need multiple security checkpoints throughout the whole system.
Exactly. And each checkpoint needs to be rock solid, rigorously tested. We're talking code reviews, automated testing, even penetration testing where you simulate actual attacks to see how the system holds up.
So baking security into the software's DNA, not just slapping it on as an afterthought.
You got it. And it's not just about the software itself either. We've got to think about the infrastructure it runs on too.
Like the foundation the house is built on.
Right. We need redundant systems, so if one part fails, there's a backup ready to go. No interruption in service.
Like a backup generator when the power goes out.
Perfect analogy. And we need solid disaster recovery plans, too.
Yeah.
So if an outage does happen, we can get things back up and running quickly, minimize the disruption.
So it's not just about preventing outages altogether, but also being prepared for when they do happen. Because, let's face it, no system is perfect.
Exactly. And this brings us to another important point. Collaboration and communication across the industry.
Sharing intel, best practices, that sort of thing.
Yeah. Software companies need to be sharing information about vulnerabilities, best practices, all that. And organizations need to be proactive about installing those security updates and patches. Everyone's got to do their part.
Right. It's about breaking down those silos and working together to make the whole digital world safer.
Absolutely. Because ultimately, cybersecurity is everybody's responsibility.
It's not just on the software developers or the IT folks. It's on all of us.
Right. And that includes individual users, too. We need to be careful about the software we install, the links we click, the information we share online.
Because even the best security system in the world won't help if someone clicks on a phishing link.
Exactly. Human error can undermine even the most sophisticated security measures.
So education and awareness are super important, maybe even the most important part of cybersecurity.
Couldn't agree more. And it's not just about the technical know-how either. It's about creating a culture of cybersecurity in organizations and among individuals. Being a little bit skeptical, a little bit vigilant, and willing to report anything suspicious.
Building that human firewall.
That's it. In the end, our strongest defense isn't just technology. It's technology plus human awareness, plus everyone taking responsibility. It's a team effort.
Well said. This deep dive has really shown how complex cybersecurity is, especially in today's world where everything is connected.
It is. And as we rely on technology more and more, cybersecurity will only become more important.
So to wrap up, it seems like this Microsoft outage was a huge wake-up call, but it also gave us some valuable lessons.
It definitely did. It showed us how crucial robust security practices are, the need for rigorous testing, and how being transparent and accountable can build trust and resilience in this crazy digital world we live in.
And it reminded us that even the most advanced technology can be brought down by human mistakes.
True. It's a reminder to stay vigilant, proactive, and adaptable when it comes to cybersecurity, always looking for ways to improve and stay ahead of the curve.
It's a constant race, isn't it?
It is. But every time something like this happens, we learn and get better, which helps us build a more secure future for everyone. It really is. But those lessons, they help us make things better, build a more secure digital world for everyone.
Absolutely. So to wrap up today's deep dive, what are some key takeaways? What can we do as individuals and as a society to make sure something like this Microsoft outage doesn't happen again?
That's the million-dollar question, right? Well, I think this whole incident really drives home the importance of what's called a defense-in-depth approach to cybersecurity. We can't just be reactive, trying to fix things after they break. We need multiple layers of protection, starting right from the beginning during design and development.
So instead of just having one guard dog at the gate, we need multiple security checkpoints throughout the entire system.
Exactly. And each checkpoint needs to be super robust, rigorously tested. I'm talking thorough code reviews, automated testing, penetration testing to see how the system holds up under simulated attacks.
So build security into the software from the ground up, not just tack it on as an afterthought.
You got it. And it's not just about the software itself either. We need to think about the infrastructure that supports it too. Having redundant systems in place so that if one part fails, another can seamlessly take over.
Like having a backup generator for when the power goes out.
Perfect analogy. And having solid disaster recovery plans, so if an outage does happen, we can get things back up and running fast, minimize the disruption.
So it's about being prepared, knowing that no system is foolproof.
Exactly. And this brings us to another important takeaway, the need for more collaboration and communication across the industry. Software companies need to share info about vulnerabilities and best practices. Organizations have got to be proactive about implementing security updates and patches.
So breaking down the silos, working together to create a safer digital environment for everyone.
Exactly. In the end, cybersecurity is everyone's responsibility.
It's not just on the software developers or the IT folks. It's on all of us to do our part.
Right, and that includes us as individuals. We need to be smart about the software we install, the links we click, the information we share online.
Because one wrong click can bring down the whole house of cards.
That's right. Even the strongest security can be undone by human error.
So education and awareness are key.
Absolutely. And not just technical knowledge either. It's about cultivating a culture of cybersecurity in organizations among individuals. Encouraging a mindset of vigilance, a healthy dose of skepticism, and a willingness to report anything that seems fishy.
So building a human firewall.
That's it. Ultimately, our best defense against cyber attacks isn't technology alone, but technology plus human awareness, plus everyone taking responsibility.
Well said. This deep dive has really highlighted how complex cybersecurity is in today's world, where everything is connected. It's a constantly evolving challenge.
It is. But by understanding the risks, taking proactive steps, and working together, we can build a more secure and resilient digital future for everyone.
That's a great note to end on. So big thanks to our expert for breaking down this complex topic for us. And to all our listeners, thanks for joining us on this deep dive into the Microsoft outage and what it means for the future of cybersecurity. We hope you learned a lot today. Stay vigilant out there.